Welcome to our discussion today of solving complex velocity problems. Today we're going to be solving problems involving two objects, and oftentimes this can be done more easily with a graph. Let's get started. So Jeremy's out in the woods, he's walking around, he notices this old abandoned bridge, or what looks like an abandoned bridge, so he walks out on it. He walks out 25 meters onto the bridge, and as he's sitting there kind of chilling out and enjoying the scenery, he notices there's a train coming at him, just entering the opposite side of the bridge, and it's going 15 meters per second. And the question is, how fast will Jeremy have to run to escape this oncoming train? So let's take a look at how to do this. So on this problem, we know that our bridge, I'll mark this, whoops, our bridge is 90 meters across. We know that the train is on the opposite side, so Jeremy came on from this side and he walked on 25 meters-ish. And so he's sitting right here, enjoying the view, right? And then, so that if he walked on 25 meters, that means he must be 25 or 90 minus 25, which is 65 meters from the other end of the bridge. So these will all be all good things to know in the future. So basically, when the train is coming this way, Jeremy is going to try to run off this way, and our train is moving this way at 15 meters per second. He's going to try and run off this way and escape the train. Hopefully he won't run towards the train, because that's not a good way to go, but he's going to run this way. So he'll have to run the 25 meters he walked on before the train gets to him. Okay, so when we do this, we'll do this by graphing the motion. So we have a train here, he's starting at 0 meters. So here's our start of our track, 0 meters. Our end is over here at 90 meters. So our train starts at 0. It's moving at a velocity of 15 meters per second. That means every second you go 15 meters. So I go over 1 second, up 15, that's where the train will be. Over another second, up 15 more to 30, that's where that will be. Over another second, up to 45, that's where the train will be. And on like this, over a second, up 15 to 60. And if I keep doing this, I find that my train will reach 90 meters right at 6 seconds. So I'll go ahead and draw a line across to represent the train, starting here and ending here. So that's the train's motion. And then for Jeremy's motion, he needs to get from the 65 meter mark. So basically he gets a 65 meter head start. He needs to get from 65 meters to 90 in the same amount of time, at least. So I'll take a line for Jeremy. Let's make Jeremy's line red. And he's going to start the 65. Here's 70, so 65 is about here. He's going to start here and have to get to the end of the tracks, or the end of the bridge, 90 meters, in the same time the train does. So I can very quickly just draw a line straight over and see what, that's a line Jeremy has to. Either that or faster. He can't go slower than that. So now to find the speed of that, all I have to do is find the rise and the run. And I'll put those two lines in yellow. So that is the run, and that is the rise. And we can see here this is starting at 65 meters, and it's ending at 90 meters. So not surprisingly, he has to go a total of 25 meters, and that's going to require him to do that in 6 seconds. So to find Jeremy's speed, so the velocity sub j, I'm going to use j for Jeremy, is equal to 25 meters divided by 6 seconds. Which is about 4.17 meters per second. So to escape the bridge, he's got to follow this red line, which is 4.17 meters per second, to be able to get off. So Jeremy can run at this speed or faster. He's going to survive. If he can't, he's going to have to jump from the train tracks before he gets to the end and take his risks with falling into whatever's below, or try to grab the train or something. I don't know. He's in trouble. So here we have a problem of with two airplanes flying towards each other. Their two friends are going to meet up somewhere in the middle between their airports. Their airports are 800 miles away. One of the airplanes can fly at 100 miles per hour. The other can fly at 150 miles per hour. The question is, if they leave the airports at the same time, where will they meet up in the middle? So they can choose an airport to land at and say hi to each other. So the airports are 800 miles away. So one will be starting down here, and the other will be starting 800 miles away. Let's call this one down here Casey's airport, and this one is Liam's airport. So they're 800 miles away. Casey's airplane can fly at a speed of 150 miles an hour. That means every hour it's 150 miles. So I go over 1 hour, up 150. Over an hour, up 150 more to 300. Over an hour, up 150 more to 450. Over an hour, up to 600. Over an hour, up to 750. There's a little bit more time. Make it to 800. Now Liam's airplane, so let me do this one in, I'll do Casey's in red. Draw a line for hers. So this is her velocity line as she moves towards Liam's airport. Okay. And then this one, we have to go Liam's now, and Liam will do in, let's say, green. And he's going to go 100 miles an hour, but he's moving towards Casey, so he's moving backwards towards Casey. So it's going to be a negative velocity, so it's going to be 100 miles every hour. So here, 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 and here. So I'll put in a line for Liam's. We'll say he starts here, and it's 100 miles every hour. Boom. Now the question is, where do they meet up? Well, that gets pretty easy with these kinds of graphs, because where they meet up is right here at this point. So if I look on here, it's a distance of about 470 miles from Casey's airport. And they meet up at a time of here, which is about 3.2 hours. So after 3.2 hours of flying. Now notice that because Casey's airplane's faster, she's actually flown farther than Liam has. She's flown 470 miles. Liam only had to fly 330 miles to get there, but because he was flying slower than Casey was. But they both took the same amount of time, so they both flew for 3.2 hours. They just flew different distances. All right, so answer the rest of the questions in that little section, and then go ahead and do the last problem. That's it for our discussion.